horizontal circles. And like this one too, like this one. This is more like a conical pendulum. We're doing that in another video. Obviously it's not a conical pendulum, but this is kind of what it does. Anyway, horizontal circles. We're going to take our understanding of circular motion and we're going to apply it to understanding horizontal circles specifically. And then I suppose once you've watched this and you've seen the video that's coming out later on vertical circles, you'll understand why we separate them. But yeah, without further ado, check out this tutorial video and it will explain everything that you need to know. Okay, so let's discuss centripetal force and how this applies to horizontal circles. Okay, so in the example here, actually if we go back just a moment so I can show you this. In the example here on the left, we have a ball here, a purple ball, on the end of a string, and this point here is its pivot point. And if you can imagine this, there was a stick here or something, and I'm swinging it around, and it's swinging in a horizontal circle. If we're talking about that situation, then there's a few components that we have to dissect. Okay, we have to dissect this into, similar when we're doing mechanics, we have to dissect this into its vertical component, which I've put here as FTY, the vertical component of the tension. And the tension being the tension in the string, which is going to be created as the ball moves around in a circle, and FTX, which is a horizontal component of the tension. Okay, now in this situation, we can say that the vertical component of the tension is going to be equal in magnitude to the weight due to gravity. Okay, and that is something that I have put here. Okay, and I think that is something that we can clearly assume and understand because we have an understanding of Newton's laws. And what we also say is that in this particular situation, which I've put here, is the centripetal force is going to be equal to the horizontal component of the tension force. Okay, so the tension force is not the centripetal force. That's something that we don't want to get confused on. What we need to know is that the horizontal component of our tension is equal to our centripetal force. Okay, so with that in mind, how might we approach this problem? Well, we have the following question, and it says that if the purple ball has a mass of 0.7 kilograms, okay, and it swings at an angle of 40 degrees, then calculate the magnitude of the tension force which provides the centripetal force. So that means that I'm looking for this, right? I'm looking for FTX. I'm looking for this here, okay? Now, how might I actually find that? Well, I think the best way to do that is to effectively treat this as a trigonometry equation. And that's why I've drawn this triangle over here, okay? Because in order to find FTX, the best way to do that would be to either have FT over here, which we don't have, or find FTY. And what we said earlier is that FTY, the vertical component of the tension force, is equal to what? We said it's equal to weight, which is equal to mass times gravity, okay? And we have mass, okay? So when we're doing these sorts of questions, we have to really break things down and consider what's going on in each step. So how can we find FTY? Well, we can say that FTY is equal to 0.7 times 9.81. And if we plug that into our calculator, we get 6.867. I'm actually doing this with you guys. Okay, and that's going to be in newtons. So we have now deduced our vertical component. Fantastic. Now, what can we do? Well, we can do trigonometry. If we know that the angle to the horizontal is 40 degrees, okay, and we know that the magnitude of the vertical component of the tension force is 6.867 newtons, and we want to find FTX, then we can say that this is obviously our opposite, this is our hypotenuse, and this is our adjacent. If we want to find the adjacent, okay, and we have the opposite, so that means that we're going to be using tan, where the adjacent where ftx, where our adjacent, is equal to our opposite divided by tan of the angle, tan 40. Okay, and that equals, excuse me whilst I do this because I'm doing this with you guys, divided by tan 40. Okay, that is 8.183, and it goes on, newtons. Okay, and that is the magnitude of our centripetal force in this horizontal circle. Okay, so I hope that helped you understand horizontal circles. Sorry, I'm just having a lot of fun. I hope that helped you understand horizontal circles in a bit more detail. Yeah, I'm changing the radius. Please like and subscribe and share. It helps us grow the channel and get more quantum content to you guys. Oh, it bounced off something. But yeah, I'll see you next time.